So why is it important to study soils? So according to Food and Agriculture Organization of United Nations, or yung tinatawag natin FAO, 95% of food is produced on our soils. Okay? So before we start, let me define what is soil. So soil is, yes? Hello, okay naman yung audio?
Yes po, sir. Okay lang po.
Okay, thank you. So soil is a natural body synthesized in profile form from a variable mixture of broken and weathered minerals and decaying organic matter, which covers the earth in a thin layer and which supplies, when containing the proper amounts of air and water, mechanical support and in part sustenance for plants. So I think your topic yesterday is about soil formation and development. So it is very important na alam nyo na yung soil natin is a natural body. So it is derived from the different soil forming factors, di ba? Yung chlorp natin. Then it is synthesized in a profile form. So meron tayong tinatawag na soil profile. So upon the interaction of the different soil forming factors, nabubuo yung tinatawag nating soil profile. Di ba yung soil profile natin, it consists of different horizons. So ano ba yung different horizons na yun, how we identify them, ay may ginagawang malaking part doon yung soil physical properties. Kasi yung soil physical properties, ito yung karaniwan natin ino-observe sa pagpo-profile. So it composed of broken and weathered minerals, which is ideally 45% ng soil natin ay binubuo ng minerals na yon, yung ating mga mineral matter. And ideally 5% is the organic matter. Okay, then the remaining 50% is for the four spaces, which is divided into two, which is 25% air and water. So these are the ideal composition. Yung 45%, 5%, 25%, and 25%. So ito yung ideal na composition ng soil. Pero in reality, iba-iba yung composition ng lupa natin. There are compacted soil. Pag sinabi natin compacted soil, of course, the solid part ng soil is mas madami kaysa sa pore space. Pag compacted yung lupa natin. Okay? Meron naman tayong mga porous soil. So, ibig sabihin, mas mataas naman yung kanilang pore spaces or yung porosity. Okay? So, that is the soil. And also, it provides sustenance for plants. So, it is very important na magtitake ng agriculturist. Dapat alam nyo yung lupa kung paano siya nakakapag-contribute sa growth and development ng halaman. Okay? So, what is soil physical property? So, soil physical property describes the nature of soil solids and their impacts in soil water and air, which is found in pore spaces between solid particles. So, soil physical property is this, yung soil physics na tinatawag natin, ang pinag-aaralan doon ay yung tinatawag nating mga soil physical properties. So, just like physics, we are dealing here with the different phases, solid, liquid, and gas. So the interaction of soil solids with its soil solution or yung soil water and soil air, yun yung interaction between them, yun yung pag-aaralan natin sa soil physical properties. So soil is called dispersed three-phase system. Dispersed means kalat-kalat or walang formation, walang distinct formation yung soil natin. So maaaring yung mga pore spaces ay may malalaki, may maliliit. So and it is three-phase system. So that three-phase system means that it composed of solid, liquid, and gas. Okay? So as you can see here in the image, nakita natin yung solid, yung organic matter, yung sand grain. So then mayroon tayong pores. So yung mga pore spaces na yan, maaaring yan ay naglalaman ng water or air. So it brings knowledge in classifying the soil profile and making field determination for suitability of agricultural crops and other environmental studies. So, di ba bago tayo magtanim ng mga halaman, we need to determine yung mga properties nito. kung pwede ba siya or suitable ba siya dun sa halaman na itatanim natin. Okay? So fertility is more easily changed than soil physical properties. So yung fertility kasi once na sinabi natin fertility, deals with the nutrient contents of the soil. So dahil nga meron naman tayong mga fertilizers, so we can easily change the fertility status of the soil, but not the soil physical properties. So soil physical properties, there are soil physical properties that are very stable, na hindi siya na-altered agad-agad. So ano ba yung mga yon? So later on, madi-discuss natin yun. So it refers to those characteristics, processes, or reactions of soil which are caused by physical forces and which can be, so soil physical property can be described by or expressed in physical terms or equations, described by visual inspection and feel, so just like your color, so you can see it with your eyes, and also your feels. So yung sa soil texture natin, we have a feel and roll method to determine that, and measure against some kind of scale such as size, strength, and intensity. So here are the list of soil physical property. We have soil color, texture, structure, density, moisture, infiltration, porosity, consistency, temperature, and tilt. So yung color natin, so di ba we have standard notation in color. So sa texture natin, we are dealing here with the soil separates, yung sand, silt, and clay. Structure, we are dealing here with the arrangement of aggregates, tinatawag. Then density, we are dealing here with the mass per unit volume of the soil. Also moisture. Moisture is one of the important property of soil. It deals with the moisture content or the water content of the soil. The infiltration, when we say infiltration, it is about how water penetrate the soil. Okay? Then we have porosity, which deals with the pore spaces or yung void natin sa ating lupa. Then consistency, yung workability ng soil, is it plastic or sticky? So yun yung consistency. Then we also have temperature and tilt. Pag sinabi nating tilt, it deals with the property of soil kung paano siya nakaka-apekto sa plant roots. So first topic is soil texture. So what is soil texture? So soil texture is defined as the relative proportion of soil separates in the mineral matter fraction of the soil. So soil separates, these are the sand, silt, and clay. So dapat alam niyo na pag sinabing soil separates, we are dealing here with sand, silt, and clay only. Okay? Tatanggalin na doon yung other solid particles na meron sa lupa. Okay? Another definition of soil texture is it refers to the relative percentage of the different soil separates such as the sand, silt, and clay. It also refers to the size range of particles in the soil. So that sand, silt, and clay has a specific particle size. Kaya sila na different between each other ay dahil sa kanilang particle size. Whether the particles of which a particular soil is composed are mainly large, small, or of some intermediate size, or ranges of sizes. So as you can see here in this illustration, sand is the larger one, then silt is the intermediate size, then yung clay is yun yung pinakamaliit na soil separates natin. So importante na dapat yung matandaan is the texture of the soil cannot be altered. So ang texture ng lupa ay hindi nababago basta-basta. Even though mag-apply ka dyan ng napakaraming organic matter, hindi mababago yan. Why? Kasi di ba yung soil texture natin, we are dealing here with the sand, silt, and clay, the relative proportion of the three soil separates. Paano ba nagkakaroon ng sand, silt, and clay sa lupa? So ang sand, silt, and clay is the product of weathering na tinatawag natin. Di ba yung weathering process natin, it takes geologic time. Okay? Hundreds or thousands of years bago mabago yung isang piraso ng isang particle from sand para maging clay. 'Di ba? Just like for example, if you observe yung stone, 'di ba yung mga bato natin diyan sa paligid, hindi naman siya agad-agad nagiging sand. Okay, hindi nababago yung size niya or chemical composition. So it takes time para bago ma-weathered yung isang particle. So kaya ang texture ng soil cannot be altered. Okay? Kasi it deals with sand, silt, and clay, which is very stable. Ito nga yung next. This is the most stable property of the soil. Stable, even though kahit na anong management practices ang ilagay mo dyan, hindi mababago yung property ng soil mo. Specifically, yung texture ng soil mo. Okay? Ang mababago lang yan once na tinanggal mo yung mismong lupa, pinalitan mo ng ibang lupa. Okay? Kasi texture is the most stable property. Then, the term carries both qualitative and quantitative. So we can determine the texture of our soil qualitatively or quantitatively. So in qualitatively, it represents the feel of the soil material, whether coarse, gritty, or fine and smooth. So just using your fingers, your sense of touch, malalaman natin kung ano yung texture ng soil natin. Okay? It feels gritty, fine, or smooth, or sticky. So malalaman na natin qualitatively yung texture natin. In quantitative sense, however, the term soil texture denotes the measured distribution of particle sizes or the proportions of the various size ranges of particles that occurs in a given soil. So quantitatively, mame-measure natin yung soil natin using laboratory equipments. Okay, like yung ating sieve, 'di ba? Yung ating sieve or yung sa landrat sa Tagalog. So by using different yung size ng sieve natin, pwede nating malaman kung ilan yung percent sand, silt, or clay doon. And also other method like yung hydrometer and pipette method. So malaman natin what are the soil separates, which is the sand, silt, and clay. So soil separates, these are the solid phase of soils consist of discrete units called primary soil particles. So soil separates is also called the primary soil particles. These particles vary widely in size, shape, and composition. Thus, soils are classified according to particle size distribution or texture of the mineral solids, since this distribution change little by little over time. So these are the three soil separates. We have the sand, which is the largest particle, the silt, which is medium size, and clay, which is the smallest size particles. So other than that, so meron tayong mga beyond 2 mm na particles or soil separates, which is yung tinatawag nating gravel. Okay, we have fine gravel. So these are the different soil separates. We have clay, silt, very fine sand, medium sand, coarse sand, fine gravel, and coarse gravel. So ito yung size nila according to International Society of Soil Science. So dito commonly sa Pilipinas ang ginagamit natin itong measurement from United States Department of Agriculture. So the particle size of clay is similar with ISSS and USDA, which is less than 0.002 millimeter. So lahat ng, for example, may sieve ka, ang size niya ay 0.002 millimeter, lahat ng papasok doon na particles is considered as clay. Then we have the silt, which ranges from, according to USDA, 0.05 to 0.002. Okay? According naman sa ISSS, ang silt natin ay 0.002 to 0.02. So medyo mas malaki yung sa USDA kasi 0.05 compared to this ISSS which is 0.02. Then we have the very fine sand which starts with 0.05 hanggang sa 2 mm. Okay? Sa 2 mm. So, pagka ginamit lang natin yung classification na sand, silt, and clay, yung clay natin is less than 0.002, yung silt natin is 0.002 to 0.05 mm, and yung sand natin is 0.05 to 2 mm. Okay? Ang pinaka-large particles natin is 2 mm. Kaya pag mag-measure tayo ng texture, di ba, anong ginagamit nating sieve? Kung na-experience nyo sa laboratory, di ba, ang sieve na ginagamit natin is yung 2 mm. So, kailangan muna nating i-sieve yung sample natin sa 2 mm bago natin kunin yung texture using laboratory analysis. Kasi yung 2 mm lang yung kailangan natin sa texture. 2 mm pababa. Okay? Then, the number of particles per gram. So, of course, dahil sa mas maliit na particles yung clay, mas maliit yung particle ng clay, per gram, madami siyang particles. So, it ranges from 50 billion particles. Okay? Then, pababa ng pababa yan. Dahil sa 1 gram, syempre, yung sand natin, dahil medyo malaki siya and mabigat, kakaunti lang yung particles per gram. Then, one of the most important property ng texture natin is yung surface area. Okay? So, dahil yung marami yung clay particles, ang surface area niya ay malaki din. Ibig sabihin, yung surface area, mas madaming nutrients ang pwedeng kumapit dun sa clay particles natin compared to that of silt and sand. So, for example, ang clay kasi natin parang sheet-like. So, parang, for example, nakikita ba yung pen? Hello, nakikita niyo yung pen na sinusulat ko?
Yes, sir.
So, yung clay natin is parang sheet-like. So, ganyan. Yung clay. So, ito yung clay. So, for example, ito yung clay, then, ito yung sand. So, example lang to. Medyo mas malaki compared dito yung sand. Okay? Then, yung surface area niya, yung tinatawag nating surface area is yung paligid nito. So, sa sand, kung isang particle lang yung meron sa 1 grams, ang maaaring kumapit lang dyan na mga nutrients or mga elements ay dito lang sa gilid niya. Sa surface niya. Compared dito sa clay, so yan lilibutin niya yung isang particles na yan, then yung isang particles na yan. Yan. So, mas madaming kakapit na nutrient dun sa clay natin. So, ang ibig sabihin nito is dahil yung clay natin ay siya yung kinakapitan ng mga nutrients, minsan yung clay natin siya yung nagdi-dictate ng chemical other chemical properties ng lupa natin, yung clay. Okay? Are you familiar with yung silicate clay natin, yung alumina octahedron and silica tetrahedron? So you will be discussing that when you review on soil colloid. So yung clay natin is yun. So yun yung maliliit na particles. So it is very important in nutrient absorption ng lupa natin. So these are the some characteristic of soil separates. So sand natin, what are the characteristic of sand? So sand feels gritty. So bakit feels gritty? Kung makikita niyo sa microscope, yung isang particles ng sand is yung may mga edges siya. So yung mga edges na yon is parang matatalim, kaya once na pinil mo sa iyong hand is gritty yung feeling. Particles can be seen with the naked eye. Hand sampling, no residue left on hand. So once na hinawakan mo yan, madali lang siyang matanggal. Okay? Hindi siya nag-adhere sa kamay mo. Okay? Hindi siya dumidikit. Then silt, we have silt, dry, powdery, smooth, fill, or flour-like. When wet, creamy, slick, slippery peel, no sticky or plastic peel. So bakit powdery or slick yung feeling ng silt? So yung silt kasi, yung single particle niyan is spheroidal yung shape niya. It means yung individual particles niyan is parang circle, walang mga edges na matalim, kaya it feels smooth. Okay? Then yung ating clay is the smallest particle. So when wet, it feels sticky and plastic. So sticky, di ba? When we use our hands, didikit yan. Magkakaroon ng slick dun sa both finger natin na ginamit. And also plastic. So pag sinabi nating plastic, ito yung makaka-form tayo ng rings. Okay, yung like for example, yung pinapahaba natin na soil when we testing plasticity of soil. So pwede siyang maka-form ng rings. Yung parang bilog, okay, na rings. Hindi siya napuputol agad. So that's the characteristic of clay. So clay when dry is a hard peel, of course. So dahil yung clay is maliliit na particles, walang pore spaces, lahat yung mga pore spaces is napupuno ng mga clay particles din. So pag natuyo yun, so it feels very hard. Okay? Particles can be seen with an electron microscope, and hand sampling sticks to finger. So ito yung mga pictures that illustrates sand, silt, and clay natin. So here this figure, you can see the different minerals and their relative distribution in clay, silt, and sand. So yung sand natin, these are galing siya primarily sa quartz and primary silicate minerals. Ito yung mga primary minerals, yung sand natin. Kasi ito yung malalaki yung particles. Then, after nang masubject sa weathering yung ating mga primary minerals, nagkakaroon tayo ng secondary minerals. So, dito naman madami yung clay natin, yung secondary minerals. So, makita nyo, sa clay natin, maliit lang yung percentage ng quartz. But upon sa sand natin, dumadami yung quartz, yung relative distribution ng quartz and other primary silicate minerals. So clay natin is mainly composed of secondary silicate minerals. Specifically yung ating mga aluminum silicate minerals, yung ating mga vermiculite, elite, kaolinite. So yan, yun yung ating mga clay particles. Dito naman sa quartz, yung mga primary minerals like quartz, feldspar, mica. So yun yung mga ating mga secondary or primary minerals. Then yung silt natin is always the intermediate between the clay and sand. So another illustration about the particle size or the particle diameter of sand, silt, and clay. So in ISSS, so clay is the upper limit of clay is 0.002, which is similar with the upper limits ng USDA classification, which is 0.002 also. Then yung silt natin, dito lang medyo nagkaiba. Yung silt natin is 0.02, yung upper limit according to ISSS. Then according to USDA, ang upper limit ng silt is 0.05. Okay, then pagdating sa sand, regardless kung fine siya or coarse, it ranges from 0.05 to 2 mm according to USDA. Then yung ISS naman is 0.02 to 2 mm. Yun yung sa sand. Okay, then beyond that size, 2 mm, yun na yung ating mga gravel o gravel. So, ito yung isa sa pinaka-importante na dapat alam nyo bago kayo mag-take ng board exam. Okay? Dapat alam nyo kung paano kung ano ba yung mga properties ng sand, silt, and clay. Kung paano sila nakaka-apekto sa other properties. First is water holding capacity. Okay, yung paghawak ng lupa sa moisture. Okay? So sa sand is low. Okay? Once na, like for example, di ba, yung ating lupa is sandy. Okay? So, naglagay tayo ng water doon, yung sand natin, hindi niya i-absorb or hindi niya hahawakan yung tubig. So, magde-drain lang agad yon ng sand. Compared to that silt na medium to high ang kanyang water holding capacity at yung clay ay high water holding capacity. Diba? So, i-relate natin ito ngayon sa crop production. Like for example, if you are planting cactus, diba ang cactus, they want dry soil or yung hindi laging basa na lupa. So, what particular soil separates dapat ang meron sa medium ng cactus. Diba? So, dapat high on sand siya. Compared to, like for example, if we are planting in the field rice. Di ba ang rice gusto niya i-submerge sa tubig, so it holds lots of water. So karaniwan, syempre, tinatamnan natin ng rice is high in clay. Okay? So dapat alam nyo, i-relate yung properties ng sand, silt, and clay pagdating sa paghahalaman. Then aeration. Aeration, sand ay good. So, alam naman natin yung sand ay malaki yung particles. So, between particles, magkakaroon doon ng mga pore spaces na pwedeng i-penetrate ng water or ng hangin, ng gases. So, aeration of sand is good, silt is medium, and clay is poor. So, karaniwan yung clay natin, di ba sila yung mga naka-compact? Once na naka-compact na yung clay, mahirap ng pasukan or i-penetrate ng gases or ng water. So it has poor aeration. In terms of drainage rate, so drainage yung pag-alis ng water dun sa soil media natin. So drainage is sand. In drainage in sand is high. Silt is slow to medium, and clay is very slow. Then, in terms of soil organic level, sand natin is low. Hindi nag-accumulate yung organic matter natin sa sand. Then, silt is medium to high. Then, clay is high to medium. Then, decomposition of organic matter. So, in terms of decomposition naman, mas mabilis ma-decompose sa sand, organic matter. Okay? Compared to silt, which is moderate, and clay is slow. Warm up in spring. So, during cold season, mas madaling warm up yung sand natin. Moderate with silt and slow in clay. Compactability. So, sand natin is slow. Di ba? Once na kahit na yung sand natin, yung sand na lupa natin, kahit na matapakan siya or ma-compress, di ba? Once na tinanggal mo na yung pagka-compress niya, babalik pa rin siya sa pagka-loose. So it has low compactability. Then silt is medium compactability and then high sa clay. Then susceptibility to wind erosion. So in terms of susceptibility to wind and water erosion, yung silt natin yung pinakamataas. Why? Kasi yung silt natin is, di ba, circular or spherical yung kanyang particle shape. So it means na hindi siya ganong kumakapit sa other particles, kaya madali siyang ma-erode or mawala sa lupa. So sand is moderate, high if fine sand. Then clay is low. Then in water erosion, low unless fine sand. So low kasi hindi siya madaling maagos ng hangin ng tubig yung ating sand kasi medyo mabigat yung particles niya. Then silt is high, then low if aggregated, high if not. So kung aggregated or dikit-dikit yung clay particles natin, very low yung kanyang susceptibility to water erosion. But kapag loose yung clay natin, it has a very high susceptibility to water erosion. Then shrink and swell potential. So very low ang shrink and swell potential natin sa sand. Then low sa silt, then moderate to very high sa clay. It depends upon the type of clay, of silicate clay minerals na meron sa ating clay. Like yung smec type or yung montmorillonite type of clay. So sila talaga yung mataas na, yung very high yung shrink and swell potential. Then sealing of ponds, dams, and landfills. So sand is poor, silt is poor, clay is good. So when we are establishing a ponds, kailangan talaga yung surface natin is more on clay. Kasi madaling ma-drain out kung ang surface na gagamitin natin sa pag-establish ng ponds is sand or silt. Then susceptibility for tillage of terrain, sand is good, silt is medium, and clay is poor. Of course, di ba na-experience natin yan, kapag umuulan, napakahirap i-cultivate or i-land prep yung ating yung field pagka high in clay content siya. Kasi they are very sticky. Then, pollutant leaching potential, so high sa ating sand. Then silt is medium and clay is low unless cracked. So, even sa nutrient leaching or other leaching process, high ang sand. Kasi once na magkaroon ng mga solution dyan, madali lang siya madi-drain out or magli-leach out. So sand has very high potential in leaching. Sa clay naman, low kasi maliliit lang yung spaces niya, yung mga micropores na pwedeng or macropores na pwedeng daanan ng water para ma-leach out or nutrients na magli-leach out. Unless cracked. Siyempre pagka mayroong mga cracks, mas madaling mag-leach out yung ating nutrients or pollutant. Then ability to store plant nutrients. So as I said earlier, yung sa particle size has to do with the ability of soil to store plant nutrients. So high yung ability to store plant nutrients ng clay kasi mataas yung kanyang surface area. Okay? Then yung ability to store plant ng nutrients ng sand is poor. Okay? Then resistant to pH change or yung tinatawag nating buffering capacity. So buffering capacity is the resistance to sudden pH change. So resistance ng clay sa pH change is high. Mataas yung buffering capacity niya or yung resistance niya kasi yung mga acidic elements, yung hydrogen and aluminum, is didikit muna siya sa surface ng clay bago makontribute dun sa tinatawag nating active acidity. So that's the property of clay in terms of buffering capacity. Then sand is low, and then silt is medium. So ayan yung ito yung isa sa pinaka-importanting part ng soil texture natin, how they dictate other property. Okay. So you're free to ask question or you can just chat in yung kung may question kayo. Okay. Then we have different soil textural classes. So yung sand, silt, and clay na yon, yung relative proportion na yon, yung relative proportion ng tatlong soil separates natin, pag nagsama-sama sa lupa in different percentage, makakabuo tayo ng mga tinatawag nating textural classes. Okay? In USDA, we have actually 12 textural classes. So i-divide muna natin sa tatlo, which is the three common soil textural classes. Yung sandy soils natin o yung tinatawag nating coarse textured soil or yung light soil. Okay? Light soil is the sandy soil or coarse textured soils. Then yung loamy soils natin, which is the medium textured. Loamy. Loamy is loamy soil or loamy textural soils is medium textured. It composed of proper distribution of sand, silt, and clay. Okay, meron siyang proper amount ng sand, ng silt, at saka clay. Then we have clayey soils. Of course, it is dominantly composed of clay particles. So this is called also fine textured or yung tinatawag nating heavy soils. So coarse textured soil are loose and single grained. The individual grains can be seen readily or felt. Squeeze when dry in hand, it will fall apart when the pressure is released. Squeeze when moist, it will form a cast but will crumble when touched. Like for example, di ba pag bumubuo tayo ng sandcastle sa beach. So it form a cast but once touch, maka-crumble agad or mawawala agad yung kanilang yung shape niya kung paano mo siya finorm. Kasi it has very low yung tinatawag nating cohesion. Cohesion is the ability of a particle to cohere with the same particle or yung magdikit yung parehas na particle sand to sand. So poor or hindi sila gano'n nagdidikit. Yun yung ating sand, low in cohesion. So another one is yung adhesion. It is very important na dapat alam nyo din yung cohesion and adhesion. Adhesion naman is the attraction between two different particles. Like for example, yung ating soil particles, which is yung sand or water, and then clay or water. So yun yung adhesion. Yung attraction between them is what we call adhesion. Then the medium textured soils or yung loamy soils natin have relatively even mixture of sand, silt, and clay. However, the clay content is less than 20%. The characteristic properties of clay are more pronounced than those of sand. A loam is mellow with somewhat gritty feel, yet fairly smooth and high plastic. So yung loamy, it has the characteristic of sand, which is gritty feel, also clay, which is fairly smooth, or silt, and highly plastic, which is the property of clay. So loamy soil composed of sand, silt, and clay. Okay? Squeeze when moist, it will form a cast that can be handled quite freely without breaking. Then the fine textured soil or yung tinatawag nating heavy soils, fine textured clay soils usually form very hard lumps or clads when dry and are quite plastic. It is usually very sticky when wet. When the moist soil is pinched between the thumb and fingers, it will form a long flexible ribbon. A clay soil leaves a slick surface on the thumb and fingers when rubbed together with a long stroke and firm pressure. The clay tends to hold the thumb and fingers together with its stickiness. So yung once na nag-measure tayo ng texture ng soil, yung fingers natin, once na pinagdikit natin, pag may naiwan na slick or yung dumikit na mga lupa sa ating fingers, ibig sabihin clayey textured yung soil natin. So other than that, 3 textural classes, these are the other textural classes, the 12 textural classes which can be found in soil textural triangle ng ating na USDA na ginagamit natin during hydrometer method. So the proportions of different size mineral particles in the soil or the relative amount of sand, silt, and clay present in the soil expressed as percentage. So, yeah. So how we determine the texture of the soil? So we have 4 methods. We have the fill and roll method or yung ating tinatawag na field method. Field method kasi karaniwan siyang ginagawa sa field. Okay? Fill and roll method. Then
dumawat ako naman nga
Hello, anyone may question? Monico Famu, you are raising your hand. Wala siguro. So, yung fill and roll method natin, so fill and roll method or yung sa ating field method na tinatawag, we have the sieve method using sieve, of course. Then we have hydrometer method and the pipette method. So, fill and roll method, so sabi ko nga kanina, using just your sense of touch, so you can determine the texture of the soil. But you need to calibrate your fingers. Dapat alam talaga natin yung kung ano yung feeling nung different texture or different texture. So field textural class determination is done by fill and roll method. Accuracy depends largely on experience, beginning with soils of known texture to calibrate your fingers. So meron tayong mga known texture. So meron tayong mga sample na alam na natin yung texture. Then ika-calibrate natin or i-test natin kung tama ba yung magiging perception natin kung dun sa correct na texture ng soil. So that's what that's how we calibrate our fingers. Then sand, again, it feels gritty and rough. Silt feels floury and or powdery. Clay feels sticky and plastic. So may nabanggit ako kanina in measuring the texture of the soil, we need to form a ribbon. So yung ribbon na tinatawag natin, ito yon. Ganito yung itsura ng ribbon na yon. So yan yung ribbon. Depende sa haba ng ribbon na ma-form kung ano yung texture ng soil natin. So just like for example here, nakikita nyo yung ribbon is medyo mahaba. So we can estimate that this soil is clay in texture. Ito medyo mahaba, medyo na-form siya compared dito. So ito we can estimate that this is more silt or loam. Then we can estimate the other one, yung mas maikli, as sand. So Diyan na may measure yung tinatawag nating ribbon. Okay? So ito yung comprehensive step sa fill and roll method. So can soil be formed in a stable ball that does not fall apart? So pag bubuo tayo ng ball, pag nabuo yung ball, so we can proceed to next step. Pero pag hindi, ibig sabihin we can identify the soil as sand. Okay? Then can soil be squeezed into a ribbon? If no, it is loamy sand. Then, if yes, another step. Pagka yung ribbon mo is longer than 2.5 cm, so proceed to another step. Pagka hindi, so proceed to another step. So that's how you determine the texture of the soil using fill and roll method. So this is for step-by-step procedure sa fill and roll method. So ayan, place approximately 25 grams of soil in the palm. Then yun nga, ibubuo ng ball. Pag no, sand. Okay, pag yes, pagka nakakabuo ka ng ribbon, proceed ka dito sa step 3, 4, and 5. Pagka hindi, so it can be loamy sand. Pag it feels very smooth, it can be silt. Then according to the size or the length of the ribbon, so less than 2.5 cm, so that can be sandy loam or silt loam. Pag yung ribbon natin is 2.5 to 5 cm, that can be sandy clay loam and silty clay loam. And then if the ribbon is 5 cm or longer, it can be silty clay or sandy clay or clay. So as you can observe, the more na mas mahaba yung ribbon, the more na mas dumadami yung ating clay content. So the other step is the sieve method. So yung sieve natin, meron na siyang specific sizes. So we need just to sieve. Ilagay natin yung sample natin dyan, then yung lahat ng bumababa na particles doon, is madedetermine na natin kung gaano siya kadami. Okay? So karaniwan natin ginagamit dito is yung 2 mm. Syempre, yung upper limit. Upper limit ng sand is 2 mm. So lahat ng bumaba sa sieve na 2 mm, ibig sabihin it can be sand, silt, and clay. So yung mga hindi pumasok doon, ibig sabihin beyond 2 mm na yon. Then sa sieve natin, pwede tayong gumamit again ng sieve na size is 0.05. Kasi yun yung upper limit ng silt. Ibig sabihin, lahat ng matira doon is yung sand. Lahat ng papasok doon, it can be silt and clay. Then, we can another use a sieve which is 0.002 yung size. So, yun naman lahat ng bababa doon, yun yung clay particles natin. So, that's how we use sieve method. And the most common na yung ginagamit sa pag-measure ng texture is yung hydrometer method natin. So hydrometer method is the most common method for determining soil texture. It follows the principles of Stokes Law. So Stokes Law states that settling velocity, which is V, for spherical particles in a viscous medium is equal to the square of the diameter of the particles multiplied by a constant K. So it gives us the equation V, which is the velocity, settling velocity, is equal to K, which is a constant, and D is the diameter squared of the spherical particles. So Stokes Law, ito yung law na ginagamit natin sa hydrometer method and also later on sa pipette method. So it is important for you to know na hindi exact, even though these are really estimates. Kasi sabi dito kanina, spherical particles. But we all know that hindi naman talaga spherical yung mga particles ng sand, silt, and clay. Diba? So it is merely an estimates. But ito yung law na ginagamit natin or the basis ng hydrometer method. Kasi kung ano yung mas malaking particle as mas mabigat na particle, siya yung una magse-settle down. Okay? Ibig sabihin, kung may sand, silt, and clay tayo sa solution, syempre unang bababa doon yung sand, followed by silt, then followed by clay. May iba't iba silang settling time. Kaya di ba pag nag-hydrometer method tayo, we need to wait for certain hours bago ma-measure using hydrometer method. Okay? So K is the constant that is relative to the acceleration due to gravity and density and viscosity of water. So K is a constant number which derives from the gravity, density, and viscosity of water. Then D is the diameter of the particle. So diameter of particle is given, di ba? We have the different diameter of sand. Sand is estimatedly 0.05 to 2 mm. Yun yung diameter niya. Then yung silt is 0.002 to 0.05. Then less than 0.002 is the clay particles. So yun yung tinutukoy dito na diameter of particle. So if you haven't seen yet hydrometer, so ito yung tsura ng hydrometer natin. For you to understand the Stokes Law, so the K value here is the gravity, then the density, and then the viscosity with the 18 constant value here. So yun yung K natin. Then we all know that velocity is height over time. So substituting those formula into an equation, so we can determine the settling time of a particle. So like for example here, calculate the time for all sand particles to settle out of a depth of 10 centimeter in an aqueous suspension at 30 degrees Celsius. The diameter of sand is 20 micrometer or 20 times 10 to the negative 4 meter. Okay, so 18 is the constant. So time, using this equation, naka-form tayo ng another equation. Okay, in computation of soil physical properties and other properties, dapat alam nyo kung paano mag-derive ng equation. Okay? Like, for example, di ba pag kumukuha tayo ng porosity, which later on madidiscuss natin, ang given doon is yung bulk density at particle density. Pero naman tayo nakakapag-compute ng bulk density kung given yung particle density at porosity. So dapat alam natin i-transform yung equation na alam natin into another equation para makuha natin yung kinakailangan nating kuhanin. So we need to know the derivation of formulas. So ito yon. From this formula, na-derive tong T is equal to N, then viscosity times height. So given naman yung depth or yung height is 10 cm, ito yon. Then yung viscosity is 0.00798. So it is derived from this viscosity of water at 20 degrees centigrade. Dahil ang suspension natin is 30 degrees Celsius, so it is modified. Then over the diameter of sand, which is 20 micrometer, ito yon. Then the gravity, and then the density. Okay, so using that formula na-derive, nakuha na yung settling time ng sand, which is 2.22 seconds. Okay, wala namang ganitong complicated na experience ko, wala namang ganitong ka-complicate na question sa board exam. More on simple computation only. Yun nga, yung bulk density, porosity, yung mga ganong questions. Basta ang katandaan nyo lang sa Stokes Law, so Stokes Law is equal to velocity is equal to the K, which is constant. Yung constant na yun ay na-derived sa interaction ng viscosity ng water, ng density, at saka gravity. Then, multiplied by the diameter or yung particle size ng ating spherical particle. Okay, yung ating sand, silt, and clay. So that's that's the beyond. Ito yung ibig sabihin ng Stokes Law na yon. Dapat alam natin yun. Yun. Then after ng hydrometer method, makukuha tayo doon hydrometer reading. Di ba ang kinukuha natin pag nag-hydrometer method tayo, kinukuha natin doon yung hydrometer reading at saka yung temperature. So yung hydrometer reading ay i-correct natin using the temperature na ginamit natin. Okay? So pag na-correct na natin yun, yung corrected hydrometer reading, meron tayong dalawang reading, which is commonly after 6 hours and after 30 seconds. So yung after 30 seconds na yon, yung hydrometer reading na yon, ay gagamitin natin sa pag-compute ng percent clay, silt, at sand. Okay? So the percent clay is equal to the corrected hydrometer reading at 6 hours. So times 100 over the weight. Okay? Yung weight ng sample natin, which is commonly 50 grams. So like for example here, the corrected hydrometer reading is 11.736. So divide mo sa 50 times 100, yan na yung percent clay mo. 23.476. Then yung percent silt natin is corrected hydrometer reading at 30 seconds minus corrected hydrometer reading at 6 hours times 100 divided by the weight of sample, which is 50 grams. So ito yon. So for example, na-compute na natin yung corrected hydrometer reading at 20 seconds, which is 24.736 minus sa corrected hydrometer reading natin ng 6 hours, which is 11.736. So their difference is 13 divided by 50, which is the weight of sample, yung ginamit nating lupa, times 100. So 26% yung silt natin. Then madali na lang ma-compute yung percent sand. So because of course the total percentage of that particles is 100%. So 100 minus percent clay plus percent silt. So ang percent sand natin ay 50.528%. Then yung percentage na yan ay ipa-plot natin sa tinatawag nating soil textural triangle. So, yung percent clay, sabi natin is 23.472. So, percent clay is andito, 23. So, for example, ayan yung 20, 25. So, 23 is, like for example, here. Yan, medyo hindi lang straight. Then, percent silt is 26%. So, dito yon. So, yan yung 26. Then, sand is 50.528. So, ito yon 50. So, yan. Kung saan sila nag-intersect silang tatlo, so, yun yung ating soil textural class. So, saan ba? So, it is sandy clay low. So, yung textural class natin is sandy clay low. So, that's how we measure soil texture sa hydrometer method. So this is the more detailed steps or procedure sa hydrometer method. So may naaalala kayo, di ba, na ginamit nating specific solution sa pagkuha ng texture, yung ating tinatawag na sodium hexametaphosphate or yung Calgon solution. So ang pinaka-role niyan, yung gamit nating Calgon solution or sodium hexametaphosphate, is to disperse the soil particles. Dapat kasi maghiwa-hiwala yung sand, silt, and clay sa lupa. Dapat hindi sila magdikit-dikit. Kasi 'di ba, kung yung clay natin ay didikit sa particles ng sand, so pag bumaba yung sand, bababa na din yung clay. So ang importante sa pagkuha ng hydrometer method ay dapat maiwan sa ibabaw pa yung clay kasi hindi pa siya bababa. So gumagamit tayo ng different solution para mapaghiwa-hiwalay yung ating particles. Kasi flocculated yan or nagkadikit-dikit yung mga soil separates natin. Kailangan natin silang mapaghiwa-hiwalay. Kaya gumagamit tayo ng dispersing agent. Okay? So I will not read this anymore. So ito yung sabi ko nga kanina, it is very important na yung soil sample natin is dispersed or dapat magkakahiwa-hiwalay na yung sand, silt, and clay. So dispersion is to make the particles exist as individual grain. So what are the mechanical agitation that we can use before we use the sample to hydrometer method? First is stirring. So kailangan natin ihalo ng ihalo, di ba, sinishake natin or shaking. Ihalo ng ihalo yung sample para magkahiwa-hiwalay yung particles or shaking. So we are also using that, or also boiling. Kasi di ba pag nagbo-boil, naghihiwa-hiwalay yung particles. Then we have chemical treatment that we are commonly using. So it depends on the kind of cementing agent responsible in aggregation. So sa pagkadikit-dikit ng mga soil particles, may mga responsible cementing agent doon. So these are the different cementing agents. And then each cementing agent ay mayroon siyang kaakibat na dispersing agent para malusaw or mapaghiwa-hiwalay yung particles. So pag yung cementing agent natin is organic matter, we need to use hydrogen peroxide. So like for example, pag gusto nating malaman yung texture ng lupa natin, kailangan muna nating, like for example, then mineasure natin yung organic matter content. Nakita natin na mataas yung organic matter content. So ibig sabihin, maraming binding agent to organic matter doon, kaya nagdikit-dikit yung sand, silt, and clay natin. So we need to apply hydrogen peroxide first bago tayo mag-measure ng texture. Then kapag ang cementing agent naman natin is calcium carbonate, so we need to dilute it by using hydrochloric acid or HCl. Then, if it's cemented by iron oxides or aluminum oxides, so we need to use sodium dithionine. And then if suspension is flocculated or dikit-dikit, so yun nga yung common na ginagamit natin sa laboratory, which is the Calgon solution or yung sodium hexametaphosphate. So, ito yung pipette method. So, pipette method is not commonly used kasi medyo sa laboratory, lalo na yung paggamit ng pipette is very kailangan maingat. So, ang principles ng pipette method is same with hydrometer method. Yung magsisettle down yung mga particles. Ang kainabahan lang, yung sa pipette method, kumukuha siya ng sample ng solution dito sa taas to measure the percent clay, yung concentration ng clay dito sa taas, sa volume sa taas. Okay? Ito yung pipette, the volumetric pipette. So within this range, kukuha ng sample, then yung kuhang sample is yung oven dry, then i-measure doon yung amount ng clay. Okay? Then computation will be done, then ma-measure na doon yung percent clay, percent silt, and percent sand. So it depends dun sa height nung solution. Kasi 'di ba sa taas maiiwan dito yung mga clay, then sa bandang gitna doon maiiwan yung mga silt, then sa pinakababa doon maiiwan yung sand. So that's the principle of pipette method. So these are the different guidelines in recording texture. So before taking records for soil texture, soil requires to undergo chemical treatment which depends on the kind of cementing agent responsible for aggregation. So dapat gawin muna natin yung kanina, yung chemical treatment para mapaghiwa-hiwalay yung particles sa lupa. So hydrogen peroxide is needed to dissolve the organic matter in the soil. Dilute HCl is needed for calcium carbonate. Sodium dithionine in iron and aluminum oxides, and if the suspension is flocculated, it needed Calgon or sodium hexametaphosphate. Then separate the fine earth fraction from rock fragments by sieving the soil sample in 2 mm mesh. So sabi ko kanina, bago tayo mag-measure na texture, dapat 2 mm lang yung upper limit nung sample natin. Kasi yun yung upper limit ng sand. Okay? Then the hydrometer measures the number of particles in suspension, the principle of Stokes Law, which states that particle will fall out of suspension at different rates over time. Based on the particle size is used to determine the amount of each particle size present in a soil. So using Stokes Law na nagsasabi na ang different particle with different size and weight ay may iba-ibang settling time or yung pagbaba. Then importance, here is the importance of soil texture. First is the indicate amount of water. So ito na yung parang role ng soil texture sa other properties and also sa plants. So soil texture can indicate the amount of water that is drained and retained in the soil. Water is retained in soil as thin films on the surface of soil particles. The tiny pools of water are held in the smaller soil pores. The greater the surface area, the greater the soil's capacity for holding water films. So, ang responsible sa absorption ng water natin is yung clay dahil nga mataas yung surface area niya. But in terms of water storage, doon siya na iipon sa tinatawag nating micropores. Okay? May macro at saka micropores tayo sa lupa. Pag macropores, ito karaniwan yung pinipenetrate ng ating roots at saka ang laman niya karaniwan is gases kung hindi saturated yung lupa. Gases ang meron. Then ang naiiwan karaniwan, yung naiiwanan ng tubig is yung tinatawag nating micropores. Okay? Dapat yung texture natin dahil nga yung pore spaces can also be affected by texture. So, maapektuhan na din yung amount of water na meron sa lupa natin ng texture. Then, second is soil texture can indicate the number of nutrients. So, that are leached and retained. both gases and dissolved chemicals are attached to and absorbed by mineral particle surfaces. The greater the surface area, the greater the soil's capacity to retain nutrients and other chemicals. Again, yung surface area, dahil nga mataas yung surface area ng clay, so yung texture na more on clay, so it has a high amount of nutrient, of absorbed nutrients compared to other texture. Then kapag high in sand naman, di ba, mas magli-leach out yung ating mga nutrients. Soil texture can determine the rate of plant nutrients that can be released in soil from weathering minerals. Weathering takes place at the surface of mineral particles, releasing constituent elements in the soil solution. The greater the surface area, the greater the rate of release of plant nutrients from weatherable minerals. Then soil texture can indicate the plasticity and stickiness of the soil. The surfaces of mineral particles often carry both negative and some positive electromagnetic charges, so that particle surfaces and other water films between them tend to attract each other. The greater the surface area, the greater the propensity for soil particles to stick together in a coherent mass or as discrete aggregates. Then last is soil texture can determine the microbial population of the soil. Microorganisms tend to grow on and colonize particle surfaces. For this and other reasons, microbial reactions in soil are greatly affected by the specific surface area. Okay, so dahil nga yung microorganism natin, they commonly attach with the surface area, of course, the clay soil has more, tend to be more populated with microorganism compared to that of sand and other soil texture. So, influence of texture on soil properties. So, it determines the soil pore space. It determines aeration. It affects soil workability, or yung ating plasticity and stickiness. Then influences nutrient holding capacity, or yung ating cation exchange capacity. It determines the available water. It determines soil drainage. So, soil texture really influences other soil properties. So I think it is the texture that is considered to be one of the most important soil physical property.